Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole.
And I'm Brian, and we're both from Calgary, Alberta.
We have some exciting news.
We've started a Patreon page.
So far on the Patreon page, there are episodes for Lake Peigneur in Louisiana, which drained into a salt mine in a matter of minutes. I know, crazy, right? And the walkie-talkie building in England, which melted a car.
I don't even know what one is crazier out of those two. But please come over and check it out if you like. You're also supporting our show, which we appreciate greatly.
We really, really appreciate it. This podcast is a lot of fun to make, but it's also a lot of work. And, aside from our time, there are costs for things such as hosting and equipment. Speaking of which, Brian, you sound a lot clearer today. What did you change?
I added a blanket to my recording setup, so it should be much better this time. I'm sorry for anyone that listened to our previous episodes, and my voice was very staticky.
In your defense, I have a little bit more practice than you. I just got a head start. Also, I think editing the podcast really gives you a brand new perspective on how you sound in your recording setup, because editing certain things out becomes really time consuming and sometimes almost impossible to get rid of. And so then you slowly figure out ways to not do them in the first place. And I, being the control freak that I am still editing the show. And so Brian hasn't had that lovely opportunity of hearing himself back and trying to, tweak that sound. So thank you for making the changes that you've made. I appreciate it. I think our listeners will appreciate it. You're certainly going to make my editing life easier. So that's great.
I'm still recording this through a fax machine, though.
They still make those?
I'm actually not sure, because I've had this one for 83 years.
You got it later in life, though, right?
Much later in life. We should hop back over to the engineering news, though.
Right, yes, we got on a tangent. This week in engineering news, an ocean drone collects scientific data from inside of a hurricane.
It's like Twister, but with a hurricane.
Right? That's exactly what I thought of when I was reading this article. I pictured that thing in Twister that all those balls come out of the cage and fly into the tornado. I mean, it's not quite the same, but that's exactly what I pictured. To back up a little, Hurricane Sam began as a tropical wave over West Africa in the latter half of September, eventually becoming a Category 4 hurricane as it continued to intensify. Once out in the Atlantic, Hurricane Sam turned north and has been traveling between North America and the European continent. Luckily, it didn't make landfall and has now been reduced to a post-tropical cyclone, so that's good news for us. Saildrone Inc. and the National Oceanic and Atmospheric Administration sent an uncrewed surface vehicle into Hurricane Sam to gather video footage and other data.
That is really, really cool. Like I know the National Oceanic and Atmospheric Administration. They have a number of airplanes that do go into hurricanes that record a bunch of weather parameters, but to send a drone in there is really cool.
Back up. Sorry, did you say airplanes?
Yes.
Are there people in them? Or are they like drones?
No. These are airplanes that have multiple people inside of them. So they have a C-130, so a Hercules aircraft goes into these hurricanes. And previously they had I believe it was a P-3 Orion that would also go into these hurricanes. But there's a squadron in the States that I believe it's a Hurricane Hunters, where their mission profile is basically to fly into the eye of hurricanes or through hurricanes and collect important data for scientists and other people so that they can do hurricane prediction and learn more about hurricane science. We should put a link to that in the show notes.
Yes, we will. I don't know what else to say because I'm still in shock that is a thing. I thought the people that fought wildfires were a little bit, nuts isn't the right word. Eccentric, maybe a little bit, likes to live on the edge, but this is a whole new level.
Yeah, the guys that fight wildfire stuff and do wildfire suppression as well as hurricane stuff, they're probably some of the best pilots around. It's a very
niche market.
No, not niche market, but it's a flight profile that requires a lot of hands-on flying skill. You're very close to the ground a lot of the time. There's a lot of turbulence. the visibility is reduced within the forest fire. There's a lot of air assets, whether it's helicopters or fixed wing aircraft that are flying very close to the fire. And it requires a lot of precision to make sure that the fire suppression material that you're dropping is dropped within a certain area and at a certain airspeed for maximum fire suppression. So I have the utmost respect for anyone that does any sort of work that's related to forest fire suppression or related to hurricane flying.
Oh, I completely agree. That is the fact that people are willingly do that is amazing. And there are a lot of homes that wouldn't be here if they didn't do that. I just, it's a little different than going into an office during the day. It's a job for daredevils, I guess you could say. It's not something I would be comfortable doing. I don't have the chops for that.
Yeah, they're great people to talk to. I've known a couple of people that have done the fire suppression route, at least. I don't know anyone that flies hurricane patrol, but the fire guys are always great to talk to and great stories, and most of them are characters. So.
Yeah, I bet. All right, back to the Saildrone and Hurricane Sam. There's a link to the article that we're pulling this information from on our website, and in that link, there's also a video of this uncrewed surface vehicle, which kind of looks like a little boat with a sail on it. I watched the video. It's not something I would want to experience firsthand, which I already kind of knew, but just watching the video, it's very, very intense. The boat battles 15-meter tall waves, 200-kilometer-per-hour winds. Luckily, it has this thing called a hurricane wing that allows it to operate in extreme wind, which is pretty cool. And the boat that went into Hurricane Sam is one of 5 that are currently navigating around the Atlantic Ocean this hurricane season, and they're gathering data to better understand the physical process of hurricanes and improve storm forecasting and preparedness. They sailed this boat right into the eye of the hurricane, and then they uploaded that data directly to the National Oceanic and Atmospheric Administration's lab, which is pretty cool. I want to say this is a great project and a huge contribution to research in understanding how hurricanes form and travel. Like we said earlier, it reminds me of the pod that they put in the path of tornadoes in the movie Twister. And I definitely don't want to detract from this contribution, but until countries like the United States start prioritizing evacuation assistance for those without or with less privilege, the extra time to prepare only really helps some people. 95 people died in the United States from Hurricane Ida, which was, in my opinion, entirely preventable. Although not as extreme, it does remind me of how during Hurricane Katrina, Amtrak offered to evacuate hundreds, if not thousands of residents on trains they were moving out of the city. But New Orleans said no thanks, and the trains left empty. We did the levees in New Orleans that failed during Hurricane Katrina in our second episode. That was that was one of the really, really early episodes, so I spent a lot of time researching that. I was still getting the show together and figuring out what I wanted to be like, and I was really, I'm still of course really dedicated to these topics, but that was very early on, and that story is very near and dear to me, and I'm still in shock of how those people were treated. So again, I don't want to detract from the contribution to science that this boat and this data is offering, but I also don't want to lose sight of the fact that we have to help people evacuate safely.
Yeah, there's a humanitarian component in natural disasters as well. I know here in Alberta a few years ago we had a massive fire up in Fort McMurray in the northern part of the province, and I feel the community pulled together very well, and people were offering friends and strangers and rides out of Fort McMurray, and there was a considerable push for air services and air charter out of Fort McMurray. So that was encouraging, and it's really unfortunate that there were empty trains that were leaving New Orleans, that were leaving no matter what, and that there couldn't be people on those trains, especially people that may not have access to funds or resources or vehicles that would allow them to escape from New Orleans and in the path of what would turn out to be a fairly destructive hurricane on a train that was leaving anyway.
Yeah, it's really sad. If you want to hear more about this unmanned boat that went into Hurricane Sam, check out the Link in our show notes to our website, which has all of the sources for this episode. And if you want to hear more about the levees that failed during Hurricane Katrina in New Orleans, check out episode 2 of our podcast, which you can also listen to on our website. And our website is failurology.ca. Not satisfied with buzzing your hair?
Don't want to pay the price of an excellent Clips haircut?
When you want a mediocre haircut for a mediocre price, Mediocre Clips is your out-of-bathroom haircutting destination.
Same burnt-out light bulbs as your bathroom, but our stylists have slightly more hair trimming experience than you do.
Mediocre Clips. When okay is good enough.
Now, on to this week's engineering failure, Apollo 1. Apollo 1 was initially designated as AS-204, and it was officially named Apollo 1 in honor of the crew that died in the fire that we'll talk about during this episode.
Spoiler alert.
Yeah, this happened quite a while ago, so I feel some people might be aware of the Apollo program and some of the early difficulties that the Apollo program had. So this was the first crewed mission of the Apollo program, which is a program that would ultimately land a man on the moon, which is a phenomenal thing to even undertake. Let alone succeed at.
If you think that landing a man on the moon never happened, please stop listening to this podcast.
Or keep listening to this podcast and we can educate you about
I
some
guess
things.
You're much nicer than me.
But to go from, heavier than air flight at Kitty Hawk to landing a man on the moon in the span of 60 plus years, or, just over 60 years, under 70 years, to me is completely remarkable. I mean, until the Wright brothers had an airplane at Kitty Hawk and, it flew for 12 seconds. We basically had balloons and helium-powered vehicles that were all, essentially lighter than air. And we never had the technology, whether it was in, aircraft design or engines, to have something that would get into the air under its own power that was heavier, that was that heavy. And in a span of less than 70 years, we put people on the moon.
We also covered the Hindenburg disaster, which was a disaster, in episode 17, if you want to check that out.
Yes. Apollo 1 planned to launch at the Cape Kennedy Air Force Station, Launch Complex 34, which is now called Cape Canaveral Air Force Station. And that's located on an island east of Orlando. Apollo 1 is scheduled to launch on February the 21st, 1967, as the first low orbital test flight of the Apollo program. And it was going to have 3 astronauts on board that had been part of previous NASA missions or programs that were part of developing spaceflight and the mission to go to the moon. So on board were Virgil I. Grissom or Gus Grissom, Edward White, and Roger Chaffee.
Did you know that Gus Griswold from the story Recess, which is a cartoon that I watched a lot as a child, was named after Gus Grissom?
I did know that, actually.
I didn't know that. That's really cool.
Yeah. So Gus Grissom was one of the 7 Mercury 7 astronauts. And the Mercury space program was the first program that NASA had that even explored spaceflight. This was at a time where they'd broken the sound barrier. Not NASA had broken the sound barrier, but the sound barrier had been broken. There were developments in jet engine technology and rocket technology. So the next logical step was to have a program that would put a man into space. And this was the space race that the U.S. had with the USSR at the time. So the Mercury program was kind of that first step in putting somebody into orbit, into space, which at that time nobody had done. It was a phenomenal undertaking, and Gus had been part of that program. The pre-flight launch on January 27th led to fire sweeping through the command module, which unfortunately killed all 3 of the astronauts while they were still in the command module on the launch pad. And this test was a plugs out test to determine whether the spacecraft would operate on internal power while detached from all cables and kind of the umbilicals that would feed power and other systems things into this rocket, into the command module. And since there was no fuel that was on board the aircraft or on board the spacecraft, this test was considered non-hazardous. So a lot of the pyrotechnic systems were disabled. There wasn't adequate preparation by the response crews. It was deemed a very low risk test, so it didn't quite have the same standards that other tests would have.
Boy, were they wrong.
really wrong.
Yeah. We're going to get into it, of course. But the fire was preventable. And that was, but that's only really half the story. There's a lot of other things that went poorly or could have gone better. And with all engineering failures that we've talked about on the show, you can't go back and change time. And the most important thing, to me at least, is to figure out what happened and why, and learn from it, and make those changes so it doesn't happen again.
Yeah, and I think with this one too, like we've talked about in other episodes, NASA very much is figuring things out as they go. Nobody's been to space before. Nobody knows really how to get to space. So they're inventing a lot of things as they go along and solving problems, as they come up, which is a big part of engineering. And sometimes it doesn't work out the way that you think it will work out.
Yeah, I mean, this is 1967. At this point in time, color TVs are a relatively new thing. Yes, you used to not be able to get those in color. Telephones all had cords. That's, cordless telephones in your house are still only a few decades old, let alone cell phones that are completely wireless. So this is definitely a tragic story. And yes, it was preventable, but still, for the things that they accomplished in 1967, it's extremely impressive. So I do want to give you kind of a timeline before the fire happened, just so you can see the events leading up to it and kind of get a feel for where everyone was at. So this is January 27th. The astronauts entered the Apollo 204 spacecraft, which was attached to the Saturn rocket on Launch Pad 34. They entered the spacecraft at 1 p.m. Grissom's spacesuit oxygen loop had a, quote, sour buttermilk smell, and they stopped the test to take a sample. But based on the results and some discussion with the astronauts, they decided to continue with the test. High oxygen periodically triggered the master alarm, and the environmental control system personnel thought that those alarms were coming from crew movement, and they didn't really resolve this. So obviously the astronauts are getting oxygen into their suits and into the module, and so they thought that as the astronauts are moving around, it's moving that high concentration of oxygen around within the inside of the module.
Yes, so the oxygen environment in the module for this test was supposed to be 100% oxygen environment, which is not something that's done now in current NASA procedures, and I believe it got revised after this Apollo 1 incident, but it's a very, very high oxygen concentration in that environment. Our atmosphere is 21% oxygen, I believe. It's 78% nitrogen, 21% oxygen. So 100% oxygen.
1% miscellaneous.
Yeah, pretty much. But either way, I mean, we're looking at an environment that has 5 times the amount of oxygen, or just a little bit less than 5 times the amount of oxygen that's typically present in a day-to-day environment.
Oxygen is extremely flammable when in concentrations that high. There were also faulty communication between Grissom and the control room throughout the test. And during the course of the test, they experienced other communication issues between operations, the checkout building, and the blockhouse at Complex 34.
Yeah, which I believe Grissom at some point remarks that, if they can't figure out communication between, 2 or 3 buildings, how are they ever going to get to the moon?
Valid point. Valid. So these communication issues eventually put the test on hold at 5:40 p.m. So they've been at this for 4.5 hours, and they've got high oxygen alarms going off, trouble with communications, and so they eventually decide that they're going to pause the test. At 6:31, they were about to restart the countdown when the ground instruments showed an unexplained rise in oxygen flow within the spacesuits. Again, they thought that the astronauts, Grissom in this case, had moved slightly, which caused the alarm to trigger.
All right, so we're onto the fire component of this episode. So 4 seconds later, after the increase in oxygen flow, an astronaut, which they believe was Chaffee, announced over the intercom, "Fire! I smell fire." 2 seconds later, White says, "Fire in the cockpit," and the fire was also seen in mission control via the cameras. So just to set this up a little bit, there's 3 guys in a cockpit that's really not much bigger than a typical bathroom. They've been bolted into, or the hatch has been bolted on to the command module, and then we'll talk about this a little bit later about the hatch design, and why that would contribute to them not being able to escape this fire. So White tried to open the escape hatch, which was the escape route out of the module. It was basically a door, kind of like an exit door, an emergency exit on an aircraft, quite a bit smaller. In order for Ed White to open the escape hatch, he needs to reach over and move a headrest out of the way, needs to operate a ratchet-like tool, and then remove the latch on the escape hatch. And so as he's trying to do this, the command module it erupts in flames, and thick black smoke starts to billow out and fills the launch escape system above the spacecraft. So as this is going on, there's technicians that are outside, and they're running to the spacecraft to attempt to unbolt the escape hatch from the outside, but there's so much smoke and intense heat that they're just overcome, and they can't approach the spacecraft until it diminishes a number of minutes later. So it's very challenging for them to do anything. And unfortunately, by the time that the hatch does open, all 3 astronauts on board are deceased. And as a result of an investigation that happened sometime later, it's determined that the primary cause of death was carbon monoxide poisoning, with thermal burns as a secondary cause.
Extremely tragic. Like, we're going to get into this, but like I said, the fire happening itself was only part of the problem. I have a really big problem with the escape hatch, but we're going to get into that.
We'll talk about that.
Yes, we will. So, as you know, an investigation of the fire, as well as duplicated conditions that were built for further testing, ended up revealing that the fire started at one of the wire bundles on the left side of the cabin in front of Grissom's seat. Any launches were postponed until NASA officials cleared manned flights, and this took about 20 months, I believe, for them to clear that. So any further Apollo or other spaceflight programs were put on hold until this investigation was completed.
Which I think is the right thing to do. I mean, this is a fairly significant disaster. There's 3 fatalities of astronauts. These guys were all highly trained test pilots. They were all very good pilots in their own regard. These were kind of the elite of the elite of the elite that were here, and the fact that 3 of them perished in this, it did need to be investigated. And if you're going to send something into space, once it leaves Earth, you can't pull over to the side of the road. So you need to make sure that everything is working, and the backups work, and the backups are working in good order.
Agreed. So there was a number of contributing factors. First and foremost, the cause of the fire was related to electrical components. Teflon, which has great fire resistance, was used as a wiring jacket, but it was easily damaged, which allowed for electrical shorts to occur.
Yeah, and so as part of the wiring jacket, there was a door, I believe it was a crew access door, or sorry, an access door in the module that would scrape over top of the outside of this Teflon coating. So over time, it did wear away that coating, so some of the wire was likely exposed just from the door opening over top of it.
And then because the cabin was highly pressurized and had a high concentration of oxygen, a spark easily ignited those combustibles that were a short distance away. There was also a leak in the environmental coolant system. The water in that coolant had evaporated faster than the glycol, and it left behind a salt formation that was highly combustible. I have a little sidebar here for you. So glycol is extremely flammable in high concentrations. And I find this really interesting because glycol used to be used in sprinkler systems in, of course, low concentrations to prevent those systems from freezing. In Prairie, Canada, where we experience extreme winter temperatures, we used to use a 50-50 glycol to water concentration in sprinkler systems, and it's still common in heating systems that are exposed to freezing. So if you have, for example, on the sprinkler side, if you have entrance canopies that are made of combustible material, you need to protect them from sprinklers, or attic sprinklers, or garages that are open to the atmosphere. A few decades ago, those would all be filled with a glycol concentration. And I find this story very interesting. In the late 2000s, or maybe 2010, there was a fire or series of fires in California where the sprinkler system had a high concentration of glycol, something like 70 to 80%. And the glycol ended up contributing to the fire rather than limiting it.
That doesn't sound like a good option in your fire suppression system if that's leading to more fire.
Nope.
It's doing the complete opposite of what it should do.
Yeah, so if the concentration had been 50-50, that risk would have been a lot lower. There is no reason in California that you need 70 or 80% concentration. I've done a few projects in California, and it's living in Canada my whole life. I don't understand what you mean when you say you can put water outside, it doesn't freeze. I don't understand. But that's what happens in California. It doesn't get cold enough. So 70 or 80% is way too high. But these fires ultimately led to major rule changes within NFPA.
And Nicole, what's NFPA?
Oh, sorry. NFPA is the National Fire Protection Association.
It seems like a good organization to be in charge of this.
I think of all the code books, they're my favorite. I've talked about them a lot on this show. I really, really like NFPA. They do some really cool stuff. So now only National Fire Protection Association or NFPA approved glycol mixes are allowed for use in sprinkler systems. Interestingly enough, none of those mixes that are on their list of approved mixes are capable of preventing freezing below, I believe it's minus 20 degrees Celsius. So we haven't been able to use those in Alberta. We easily experience minus 40 every winter for several days. And in Calgary, we get the benefit of Chinooks that they don't see in Edmonton, Saskatoon, Regina. So in Canada, specifically the prairie provinces, which experience those more extreme winters, we have to use a dry system. So that means that all the piping is installed, but no water is put in. And there's a series of sensors that would detect a fire, which then opens a valve and allows water to flow into the piping and discharge from the sprinkler heads that need it.
So is that for inside use or outside use?
Anywhere that is subject to freezing.
So my condo has an integrated fire system, and it actually, unfortunately, it was deployed a number of years ago when there wasn't a fire, which led to me having a waterfall out of the ceiling. Great for pictures, not great for the rest of my condo. So in that system, would that have glycol in it, or would that just be a water and another, like a foam suppressant or a different kind of suppressant in there?
That's just water, just straight city water.
Just straight water, okay. Yeah. That doesn't smell very good. That does not smell very good.
Yeah. Okay. I'm going to address the foam first, then I'll come back to the smell. So foam is almost only used in server room applications or areas where you have equipment that is very important, that has a very important purpose, and you don't want it to get wet. That's where the foam is used because it suppresses the fire without damaging the equipment. The foam systems are very expensive. The smell. So those pipes are filled with water when the building is built. I think your building is 5 or 6 years old.
My building was built in 2015, and this incident happened in 2018, I believe. So that water had been sitting there for a number of years. It was 2017 or 2018. So 2 or 3 years of the water just hanging out in the pipes, and then there was an incident that happened, and the fire sprinkler systems went off.
Yeah. Gross. So if it's been sitting for a really long time and black stuff comes out of the sprinkler head, that's called sprinkler cheese. It's the most disgusting thing. Don't look it up. It's something you can't unsee. You don't want to look at it. It's really gross and it smells really, really bad. But yeah, it's called sprinkler cheese. I also want to say one more thing and then I'm going to move on because I have gone off on a tangent. When a sprinkler head goes off, it's not like the movies. They don't all go off. So there's a little bulb inside the sprinkler head, and when that bulb sees a certain temperature, it breaks, and then that's the head the water comes out of.
So I think I'd seen this a little while ago. The color of the little glass tube, I believe it's glass tube in there, those are all based off different temperatures, right? Like the ones that I have in my condo, I believe they have like a red. They have a red color in them. But then when I was looking online, like there were ones that had different colors for different temperature settings for when they're activated. Is that?
That's correct. Yeah. So thank you, National Fire Protection Association, for bringing these fun facts about sprinklers. Apollo 1 did not have sprinklers. This was actually, NFPA has been around since 1913. So this is well after Apollo 1 accident was well after that, but probably before a lot of buildings had sprinklers in them. Well, I've definitely done lots of 1960s retrofits that are completely unsprinkled until we're done with them. So thank you for that tangent, NFPA. Let's get back to Apollo 1.
All right. So like we mentioned before, the spacecraft environment within the capsule, it had very high pressure and high concentrations of oxygen that contributed to the quick spread of fire. Also with that, there were a lot of combustible materials that were inside of the capsule that NASA doesn't use currently, largely as a result of Apollo 1. So there were debris nets along the command module that prevented items from dropping into equipment areas during tests, which were basically Velcro. So it was great for the astronauts and any of the technicians to be able to stick stuff right onto these Velcro walls. It was there, it was accessible, but it's Velcro, so these were made of nylon and other highly combustible materials. And NASA was aware of this risk, but they didn't anticipate a fire during this, what was supposed to be a very low risk test run. So they allowed the nets to remain in place and on the ground with the intention of removing them before spaceflight. Unfortunately, this Apollo 1 command module didn't get to spaceflight, and having the very highly flammable Velcro within the spacecraft high oxygen environment significantly increased the combustion that occurred within the command module.
So now we're going to talk about the hatch design, which may not be the biggest contributing factor, but it's the one that bothers me the most.
Yeah, so I share the same view of that this is one of those things that, just like fire doors, the way that fire doors, they always have to open outwards rather than inwards. It's kind of the same thing with this hatch.
Yeah, and it might be my over a decade of experience in engineering, but just because you don't think there's going to be a fire, you should always plan for worst case scenario. And to be fair, I understand that you can't just have a push bar to open a hatch in space. I get that. This hatch has to be secured so that it can't accidentally be triggered, or you would have, astronauts potentially perishing in space because that's not an environment that's built for humans. But I do think there's some improvements that could have been made. So, as you may have picked up on earlier, the hatch was complicated and it took about 90 seconds to open, which was definitely too long. It also had a relief valve, which normalized pressure, but that valve was not large enough to have any impact in the event of the fire. So there was just too much smoke to be able to relieve through that valve to make any kind of impact on the quality of the air inside the module. And then, of course, as Brian mentioned, exit doors open out, but this hatch opened into the module. So due to the high pressures that occurred during the fire and during this test, it was almost impossible to pull that hatch into the module in order to open it. So, I think there was a lot of things with this hatch design that were working against them. And I get that they didn't expect the fire to happen, but I do think that not a lot needs to change with this hatch design, I don't think, to make it significantly better, but some things need to change.
Yeah, especially, and this did get incorporated into further designs, just the way that, people outside of the command module could open the hatch. They added explosive bolts back onto this hatch, I believe. So that way they could be remotely activated for somebody that was standing outside of the fire. So there were a couple layers to the hatch that needed to be removed before the astronauts could get out. And like Nicole mentioned, it took a really long time for the pressure to equalize or for the cabin pressure to dump out before the astronauts could actually, get out. And, as well, the just with the way that the hatch was designed, it was very difficult since it opened inwards for the astronauts to use it to get out of the command module, which is, unfortunate. And I think that likely contributed to the deaths of all three astronauts.
While there are a number of contributing factors, and we do have one more to talk about, the hatch design is definitely the one that bothers me the most. I'm just not happy about it. So the last contributing factor we're going to talk about is NASA's mismanagement of this fire and rescue. The review board determined that the organizations responsible for planning, conduct, and safety of the test failed to identify all of the hazards that we just mentioned. And these problems existed and were made worse by governmental pressure to minimize cost and time, as well as a lack of communication between NASA and its contractors. So, I wasn't there at the time, but it is my understanding that there was a big push from the United States government to put a man on the moon. And so along with that comes added pressure to have, this process go smoothly, to be successful, to get a man on the moon quickly. And so sometimes when things like that happen, I'm not going to say they were cutting corners, or they were pulling shortcuts, but
there's outside pressures. There's outside pressures that are happening certainly at this time. This is really, I feel like the height of communism, versus capitalism, essentially the height of the Cold War.
Who was president at the time?
Uh, so when this is happening in 1967, so Lyndon B. Johnson is president of the United States. But yeah, there's a big space race going on between the USSR and the USA for who can put a man onto the moon first. And Lyndon B. Johnson especially sees this as, something that America needs to win. They need to show that they're better than, communism in the USSR, and they have more technology, and they're the better nation out of this. So that may contribute a little bit to, like Nicole mentioned, possibly cutting corners or, putting things through a little bit quicker than what we would typically think would be an acceptable review and design process. So out of the Apollo 1 disaster, there are a number of recommendations that are made. So some of these recommendations for future missions: oxygen should be restricted or controlled. Safety needs to be the primary design consideration, and emergency personnel should be available for any sort of testing that occurs.
Yeah, those all seem really straightforward. And, we've covered a number of failures on this show. And I would say that every time I read the recommendations for what to do to prevent that failure from happening again, I think the same thing. They're always so straightforward. It's like, how did we miss this the first time?
Yeah, but I think if we look at not just engineering failures, but a lot of, disasters that happen, whether it's, aircraft crashes or, car accidents or, other design failures, there's always something that, looks like it's a glaringly obvious thing that should have been implemented that for whatever reason wasn't implemented or wasn't followed. And, a lot of the time, unfortunately, people do pay, with their lives or with limbs. And what we hope is that, once things get investigated and new policy and procedure comes in, people are more cognizant or aware of it. And the reason that we have policies and procedures in place is to protect people. And a lot of those policies are a result of somebody not going home at the end of the day.
Yeah. So in Canada, I've recently, I'm in the process of going through getting some professional designations. I have some already. I'm getting more. And I wrote my ethics exam a little over a year ago. And, the most important thing, your first duty as an engineer in Canada is to public safety. That is your number one job above everything else. And I think it's important that we remember that, because that really is the most important thing. So as we mentioned, any future manned missions were paused for 20 months after this incident occurred to allow them some time to investigate and figure out what happened and learn from it and correct their mistakes. So the next manned mission launched on October 11th, 1968, and that was Apollo 7. And it included the following improvements. It had an onboard TV camera, S-band radio communications, a fire extinguisher. Imagine that, a fire extinguisher on board.
Those seem pretty important.
Right. It had emergency oxygen masks, less combustible material, better wiring, and a new system to minimize the volatility of atmospheric conditions.
So there you have it. What was meant to be a non-hazardous test and something that should have been very straightforward for the first crewed mission to the moon turned out to be a devastating event for NASA and space travel in general. Like all the engineering failures that we've covered on the show, and as tragic as it was, there's a lot to learn from not only how the fire started, but how it spread and how really the rescue was mishandled.
For photos, sources, and an episode summary from this week's episode, head to failurology.ca. If you're enjoying what you're hearing, please rate, review, and subscribe to Failurology so more people can find us. If you want to chat with us, our Twitter handle is @Failurology. You can email us at thefailureologypodcast@gmail.com. You can connect with us on LinkedIn, or you can head on over to our Patreon page to check out our mini failure episodes that we've put out so far and support our show. Check out the show notes for links to all of these. Thanks everyone for listening, and tune into the next episode where we'll talk about the Leaning Tower of Pisa.
And this is slightly different than the Leaning Tower of pizza boxes that I had in university.
We couldn't decide if this was an engineering failure or a marvel. I mean, I don't think they designed it to lean, but it's also still standing. So we decided to put it halfway in between the Engineering Marvel specials that we do every 10th episode, and we decided to put this at episode 35. So check that out next time. Bye everyone. Talk soon.